Yep, so my name is Jared Watts, and I'm going to be kind of walking us through a tutorial or a practical approach for how we can build your own cloud platform using Crossplane. So let's dive right on into it. There we go. So we just heard Cheryl Hung from the CNCF talk about how complexity is the #1 issue that end users in the cloud native landscape and ecosystem are facing. And it's kind of funny that she said that that goes all the way back to 2017 too. So it's a multi-year problem we've been dealing with here. And so one of the things that we're seeing a lot is that the cloud native landscape has an enormous amount of really useful projects, but it would be really helpful if we could start getting complete solutions around those, start putting all these projects together into, turning these ingredients into recipes, complete with best practices, that operational knowledge, everything you need to be successful in the cloud native landscape. We're going to take a look right now at how we can start building one of these ourselves. So a quick bit of background here again. So to recap, Nick earlier talked about, how you can build your own API with Crossplane. And so we're just going to revisit that again real quick. So basically, you can define and compose your own infrastructure APIs as an abstraction on top of lower level cloud service primitives. So for example, is like a MySQL service, you want a MySQL API for your application teams. You want them to be able to create a MySQL database on demand when they want it, right? And so to do that, to define this MySQL API, it's actually composed underneath of a number of different resources underneath. Like in Azure, it'll be a MySQL managed service. You'll have a resource group for all of them to contain all the resources, and then you'll have a firewall rule for the ingress into the MySQL as well too. So you can define this MySQL API. It's going to be composed of all these individual components, these resources underneath it, and all that infrastructure complexity, and then your policy, your guardrails, configuration, et cetera. That's all going to be beneath that API line and hidden away from the end users, your app teams that are interacting with the MySQL API. Best thing here, you don't have to write any code to do this. It's declarative, right? So like a little visualization here to kind of put this together is, let's look at this diagram from left to right. So think about your application developers, your app teams. They're going to be interacting with a simple API. So today we're going to build a cluster API so that devs can get their own clusters whenever they want one on demand. And so what they interact with is the cluster API, a cluster object in Kubernetes. But behind the API, there's a set of implementations of that cluster API. So we call them compositions here. So underneath cluster is for AWS, you're going to have an EKS cluster, VPC, security groups, all sorts of things, AWS resources that actually compose that cluster API. And similar for Google Cloud, you'd see a GKE cluster, network subnet, and a node pool for the worker nodes, et cetera. So these compositions or implementations underneath the API line when the user just interacts with that cluster API. And then we package all that up here into a what we call a Crossplane configuration. So this is where we start getting to those solutions where we have entire infrastructure and service solutions packaged up into reusable bundles here. All right, so we're going to look at a real world example, and you can follow along at home as well too with this repository. It is published, it's an open source repo underneath the Upbound org in GitHub, and it's called Platform Ref Multi-K8s. So basically we're going to be defining a multi-cloud Kubernetes API, and that's going to allow our developers to create their own clusters in their cloud of choice whenever they want to. And this is where the recipes aspect comes into play, where they'll get a cluster with the batteries included, where they'll have, instead of a number of individual cloud native projects to work through, they'll get a whole solution of them all put together, such as all the monitoring and logging, observability stuff that will come along with it. So they get a full-fledged cluster with all the batteries included. So let's start building this API. So here, a quick checklist is what we're going to be walking through today. So 6 steps. The first one, we will just define some package information, general information about the package, some of its dependencies, et cetera. Then we'll define the API that we'll want to expose to our app teams. And then we'll define all the resources underneath that API. We'll start making compositions that will fulfill the implementations of that API. We'll build it and we'll pack it into a package and we'll publish it up to a registry. And then we'll install a package into a control plane. And then we'll go ahead and let our app team consume it as well too. So let's work through the checklist here. Checklist step 1. So we're going to define the basic information about our Crossplane platform, our configuration we're building. So we could specify simple metadata like who wrote it, who's the maintainer for it, what the license is on it, et cetera. You can put a rich README in there, user guide, documentation. You can put all that type of rich metadata in there as well too that would display in the registry that it gets published to. But an important part we'll look at here as well is being able to specify what version of Crossplane does this need and what are the dependencies, right? So multi-cloud Kubernetes implementation here that we're building, to be useful, it's going to need GCP, it's going to need AWS, it's going to need Azure, et cetera. It's going to need all the major cloud providers so that it actually can run, and resources that compose that API can be spun up in those clouds of choice. So if we look real quick at the code in our crossplane.yaml file here, what we're going to see is a spec section for our Crossplane configuration object, which just specifies what version of Crossplane we need, and then all these providers I was talking about, as well as the versions that we want of those. So the beautiful thing here is that it's got automatic dependency resolution. So we just say, hey, I need AWS, I need GCP, I need Azure, I need Alibaba, whatever you might need. And at runtime, Crossplane will make sure that those are all installed and running as well too. So that's simple package information, nothing to it. And then we will go on to step 2 of actually defining the API. So this is where it gets a little bit more interesting, I think, where we are going to be creating a composite resource definition, an XRD, if you will, that really defines this is the surface area, this is the API that our app teams, our developers are going to be interfacing with. So if they want to create a cluster, what are we going to need to expose to them? We're going to expose some configuration settings, but obviously not everything. We don't want them to have full control over all of the details and the complexity of the environments underneath, right? So for this example, we're going to say, okay, we'll let them define the number of nodes in their cluster when they create it, and then the size of those nodes, just in very general terms. And remember, this works across all the cloud providers as well too. So it'll be a very general description of how they want their cluster to be created. And then maybe we'll let them install or specify some versions of the batteries included, the cloud native projects that we're putting into a recipe here. So we'll let them talk about what version of Prometheus or Fluentd or any of these other number of projects in there. We'll let them specify some versions. And here's a really important concept. So there's a concept above the API line and below the API line. So above the API line is just a simple configuration we're letting our developer team use or specify. And then below that is going to go all of our policy, our organizational configuration, the guardrails, all this environment details will be below the API line. So let's take a look at an example of that too. So here is where we're defining our cluster API. So we have a composite resource definition object, and this looks a little daunting at first, but it's actually quite simple. Just a lot of specification in the YAML here that we're going to look at. So we're saying we're creating a cluster API. This is what we're going to allow our developers to create their clusters on demand with. And so we wanted to define what is the shape of this API, what are the settings that we want them to be able to set. So that's currently defined in Open API v3 schema, just like CRDs are in Kubernetes. So you can imagine standardized tooling, the same things to be used, you can kind of generate Kubernetes CRDs, you could start being able to use to generate these type of resources as well too when you're defining your APIs. But basically we're going to say, hey, we're going to let you define the count of nodes in the cluster, and we're going to let you define the size of the nodes in the cluster, small, medium, and large. So this is defining the shape of our API that we're exposing to our users. Then step 3, what is beneath the API line? What are the resources that are in the AWS and in GCP that actually compose this cluster resource, right? So, we can have multiple implementations of this. That's what a beautiful thing. User asks for a cluster. They can, underneath the covers, they can get one in AWS or GCP, or you can work on different dimensions as well too. Maybe a fast cluster or a cheap cluster, maybe a bronze cluster or a gold cluster. You can have multiple implementations for the compositions that are underneath the API you're defining for your application teams. That's, as we mentioned, that's where all the policy and configuration goes. And this is a place where we put our recipes as well too. So when we're saying that we wanted some of those cloud native projects in there, like our maybe Jaeger or maybe Fluentd or maybe Prometheus, we can put those as compositions inside of our the objects that are created or underneath our cluster API as well too. Now, here's a really important concept I want to go over with us real quick. I think we still get good on time, is that patching is a really, really, really important concept here. So let's take a look at what patching means here. So patching, here's our EKS composition, but we're going to look at the GCP composition instead. So this GCP composition is on GCP, what does a cluster mean? And so we've got a couple of base resources on GCP. Cluster means GKE cluster, and it also means a node pool object as well too, and then a network or a subnetwork and things as well too. But when app developer asks for cluster, they get GKE, they get node pool, etc. So patching though means that the user-facing configuration settings, such as the size of a node or how many of those nodes, we need to get that from the user, from the cluster API, down on in to these primitive managed resource services here, like GKE and node pool, so that they'll actually be made to happen in reality inside of GCP. So in our patches section for the node pool, we're going to take from the users, the end users API, the size that they said, and we're going to patch that down to the machine type for the node pool. And we're going to map small, medium, and large to different instance types in GCP. Same thing would happen in AWS, where we'll take small, medium, and large and map that to a different set of machine types that are actually relevant to AWS. So we're patching the user's config on the cluster API down into the resources that compose that API underneath. Step 4 is we're going to build and publish this thing. So we've built our APIs, we've built the compositions underneath the APIs. So now we're going to use the kubectl Crossplane plugin. We have a Crossplane plugin for kubectl. And then that will build it and do some schema validation up front to make sure that there's nothing invalid with the schema or there's no errors, so we can kind of shift left and validate those up front. And at the end of the day, what we're going to end up with is an OCI compliant image. And we can publish that to any registry. In the example here today, we're going to be publishing it to the Upbound Cloud registry, but it could go to Quay.io, it could go to Docker Hub, it could go to Harbor, any OCI compliant registry, we can publish to there. And then once that our package there is published, then we can install it. We can install it into a control plane to kind of teach that Crossplane cluster about this new API. So a Crossplane cluster doesn't know what a cluster API is at first until we install our package that we built and published. And then the package manager will do the dependency resolution. So all the providers, AWS, GCP, Alibaba, et cetera, will get automatically installed so that they're part of the control plane as well too. And then all our new types, our cluster API type that we taught it, and the controllers to reconcile those, they'll all be automatically put into the control plane. So the control plane is up and ready to service your app teams when they're asking for their clusters. The final step, since that's on the control plane now, is to actually consume the API. So as an app developer, you as the infrastructure owner have created this cluster API for me. And so from my perspective now, I see a new cluster object. I can now create instances of clusters and interact with the API you've designed for me. So I could say, hey, I want a cluster and I want, to advance the slide. I want 3 nodes in my cluster and I want them to be small. And I want this particular version for Prometheus. Underneath the covers, right, that's going to result in the GKE cluster, a network, a subnet, a node pool, all these things, all my policy, all my complexity of the environment details, all that is completely abstracted away from me as an application team member, as a developer here. And so this could be, we can get some security in place too, to only let certain developer teams or certain entities have access to it. You can use consistent Kubernetes RBAC to gate access to that. And when our cluster is done, when we've created our cluster object and all the machinery runs, the kubeconfig, the connection information will be stored in a secret right next to this cluster object that I have created as an application developer. So let's look at this real quick, more visually here. To see what that experience is like. So as we mentioned, I published it up to registry. So this multi-cloud Kubernetes exists on the Upbound Cloud registry at upbound.io. And along with some other providers and other types of reference platforms or recipes that we've designed for you all. And then here's the really important part. So I'm a front-end developer, right? I'm an application developer. I log into Upbound Cloud, and what I see is basically a custom cloud console. The API that my infrastructure team designed for me is what I see when I log in, similar to go AWS or GCP cloud consoles, and you see all the services listed on the side there that you can create. This is the exact same thing for me, where I'm allowed to create a cluster now. So I click on the cluster. I don't have any yet. I can create it now. And I get a nice rich UI here that's generated from the package, our metadata that we defined. And I can say how many nodes I want. I can say, I want the large ones. I'm going to say that I want it in GCP. You can imagine too that we can put some policy in here underneath to say, oh, if you want this many nodes, then it can't be large or something for cost control, things like that. But basically, I get a custom cloud console that is the API that my infrastructure team has designed and published for me. So wrap it up, I think we're just over time here. We stepped through all of the steps there, the 6 steps necessary to create our own infrastructure API and to publish it and to have our application teams consume it. And that is basically the end of the presentation here in the demo. Quick note here is that slack.crossplane.io on our Slack, we're super available to start helping you all build your own platforms as well too, because this was absolutely a lightning kind of blitzkrieg through this topic here. And there's a lot of details and things to learn. But if you join our Slack, we're happy to talk more about how to do all these things and help you build your own platforms as well too. And if you like what you see and you want to join the Upbound team, upbound.io/openings, we've got a ton of great jobs and career opportunities out there for you as well too. So thank you, Dan.